All right, here's 13 and 14 from the EOC practice questions. and these are ones that we've done before in class to some extent. And so I just wanted to show you, kind of make sure you know how it relates to the graph. And so you can do it if you're given the graph or if you're given the function, right? And the lesson that we did, we were given the function, right? Like this is it was a lesson 4.4 or something like that. Okay, but we were given that and we were asked to find the amplitude in the period, right? This time we're going to add in the midline. I think I talked about it a little bit, and I put in our math rules, or when we looked at the math rules, I think I pointed that out. But it's pretty easy to do, so I just want to throw that in there just in case that's something that comes up. Okay. All right. So let's say let's start with 13, and let's say we're looking at the graph. Okay. So the graph, the midline is the line that goes right in the middle, right? So if you kind of think of like, there's a line at the top, okay, and there's a line at the bottom. So the midline is the line that goes between those two lines, right? So if I think of this whole distance as 1, 2, 3, 4 units, the middle of that would be 2 units, right? So 1, 2 from the top, or 1, 2 from the bottom. So basically, let me just delete some stuff here. So basically that's going to be this line right here, okay? So that's the midline. And the midline is always horizontal, and so it's going to be y equals, and in this case it crosses through 2, so it's going to be y equals 2, okay? Now, so if you're on a multiple choice question and they ask you what's the midline and they give you x equals a number, that's not it, right? You can cross that out right away, because x equals would be a vertical line, right? It would be coming through something like this, okay? All right. So it's always y equals a number, okay? Now let's say that you were given the function, right? Let's say that you were given this without the graph. So then the midline is this number right here, and you just set it equal to y, right? So that's how we find the midline. Okay, so let me put this in purple here. So the midline is either the middle of the graph if you're looking at the graph, or it's this number right here and you set it equal to y. Okay. All right, cool. So now that we find the midline, it's pretty easy to find the amplitude. Okay. So the amplitude, first of all, if we're looking at the graph, it's from the midline to the top, right? So what's this distance right here? And you could do it right here too, right? It's the same everywhere. You could also do it down here. But just what is that distance from the midline to the peak or the valley, right? And you just count it, 1, 2. So that's 2, right? So the amplitude would be 2. And the other way we know to find it that we've done before is look at that number that's being multiplied by the trig function, right? So here our amplitude would be 2, okay? So let me write the midline down there just to have that too. So so midline is y equals 2, amplitude is 2, and now for the period. So the period, we can't just look at it, right, like we did with these other ones. We actually have to do a little bit more work, but it's not too bad. So for the period, what we do is we look at this number here, and if we're in degrees, which, so if you don't see pi, you're in degrees. So for the period, for sine and cosine, remember you do 360 divided by whatever that number is in front of theta or in front of x. That theta could be an x sometimes, but whatever that number is that you're multiplying by theta, excuse me, or x, you just do 360 divided by that, right? And so that'll give you the period is 180. All right. Now let's say you're looking at the graph. The graph, look at where it crosses the y-axis, the y-intercept, and then see where it gets back to that point, okay? So, and you might be thinking right here, but remember, that's not the full cycle. So the full cycle through the pattern is when it comes all the way down, all the way back up, and then it starts coming down again, right? So that's the full cycle in the pattern, okay? And so see how it's like right here, it's coming on the down slope to get to that point. So when we start here, that's where this ends, right? So if I took this piece right here and I just snapshotted it and I attached it right to the end here, it would come and it would just like follow itself. I could just repeat that pattern over and over again, right? And so that's what the period is, just one cycle in the pattern. So how long does it take to get from here to here? 180 degrees, right? From 0 to 180. So that's what I usually do, is start at 0, right? Start at the y-axis, and then see when it gets back to that point, and whatever that is, that's your period. Okay? All right, cool. So that's how you do it graphically, and that's and you can also do it with the function, right? So they can, you know, either way they give it to you. This isn't that hard of a problem, although, you know, trig functions are a little bit different, weird. We haven't, you know, gone too much into depth with those, but we definitely have talked about the graphs and the amplitude and the period. And so, you know, so hopefully this reinforces all that. All right, so that's number 13. Number 14 is the same thing, but we have pi involved, right? And so that means it's going to be in radians. Okay, when you see pi, that means you're going to deal with radians. Okay, and pi is, you know, pi is normally what you think, like it's approximately 3.14159, etc. So it's the same pi as you're used to, but instead of degrees, it's radians. Okay, and this is on your reference sheet, but pi equals 180 degrees. Okay, or 2 pi equals 360. Okay, so those are your conversion factors there. Excuse me. All right, so now as far as what they're asking us for, right, the midline, the amplitude, and the period, those are actually very, very similar, except when we get to the period, that's when we'll have to incorporate this kind of stuff. Okay, it'll be a little bit different than we're used to, but fairly similar. All right, so first of all, let's talk about the midline. So if I'm looking at the graph, then I want to look at the peak and the valley. I'm going to get right in the middle of those, right? So the middle there between those two is going to be right in here, right? So it's 2 from the top and 2 from the bottom, right? And that gets me to the midline. So let me clean that up a little bit. So here's the midline. So it's going to be y equals -1. Okay, so midline y equals -1. Okay, now remember, you can also do that by looking at this right here, right? So that's how another way to find the midline is to just look at the equation or the function, and then whatever that number is that you're subtracting or adding at the end, and it could be in the beginning too, but it's the number that's not attached to the trig function, right? That's you set that equal to y, and that's your midline. Okay, so we got that done. Now let's talk about amplitude. Amplitude might be the easiest thing. If we're looking at the graph, you know, we just want to look how high is it from the midline to the top, and we can just count that out, 1, 2, so it's 2 units. Or we can look at this, right? So amplitude is 2. Okay, that's pretty easy to find either way. And then now for the period. Okay, so for the period, normally we would do 360 divided by that number right there, right? But instead of 360, now we're going to do 2 pi, because that's what equals 360. So we'll do 2 pi divided by 2, and that equals pi. Okay, and so that's our period, is pi radians. You can just put pi, you don't have to put radians, because when you see pi, it basically implies radians with trigonometry. Now real quick, how do we do that on the graph? So remember, we start on the y-intercept, and then we figure out where does it get to that point in the cycle again. So we're coming right after the peak, right? So I want to go through the cycle all the way down, all the way back up, and then a little past the peak, right? So right about in there. Okay, and if you look at that from 0 to here, that's pi, right? And so however long it takes you to get a full cycle from the y-intercept back to that same point on the graph, then you look at that x value. In this case, it's pi, because we're talking radians, and so that gives you the period. So that gives you the same thing as what we got by using the function. Okay. All right, so a couple of different ways to do the same thing, either by giving the graph or by given the function, and we did it with degrees on number 13, and we did it with the radians on number 14, okay? All right, so cool. So keep working hard. Let me know if you have any questions on this. I know it's a little different, but let me just label this. This was degrees on this side, and this was radians on this one, okay? And they're, remember, degrees and radians are just two different ways to measure angles, and it's kind of like feet versus centimeters, you know, or inches versus centimeters, you know, just two different ways to measure length. This is two different units to measure angles, okay? All right,